I don't want to say a lot to do today, but we got a good bit. Okay, so just a reminder, slope formula is going to be y2 minus y1 over x2 minus x1. It really doesn't matter which point you label what. They just need to go in the right spot. So for instance, this one right here is going to be -1 comma -1. Let's just label that as x1, y1. Over here, this is 2, -2. That's going to be x2, y2. Okay, and then we're going to plug this in. That's going to give me -2 minus -1. That's going to make that plus. And then 2 minus -1, which is going to make that one plus. And so this is going to give me -1 over 3. You can also see this visually. You can see that you went down 1 and to the right 3. Okay, so that slope is -1/3. On the next one, we've got these 2 points. This is 0, comma -1. And then this one is -1, comma 1, 2, 3, 4. -4. Again, you're going to label. And then you're going to plug in. So -4 minus -1 over -1 minus 0. So this is going to give me -3 over -1, which is going to be +3. Again, we can see this visually, up 3 over 1. So on the next one, they only give you the points. They don't actually give you the graph. So if you're able to plot it, that's fine. Now, if it was like a fraction, like if it was like halfway in between, then you would have to use this formula. Yeah. All right, so looking at the next two, you're going to label these, and then you're going to plug them in. Okay, so x1, y1, x2, y2, and then I'm going to plug in 14 minus 10 over -7 minus 8, and that's going to give me 4 over -15. On the last one, x1, y1, x2, y2, this is going to give me -8 minus -5 over 0 minus -12. And that's going to give me -3 over 12, which can simplify to -1/4. Now, again, you could plot these and see it visually. But if it's a decimal, you're probably going to want to use the formula. Okay. And these are the triangles and parallelograms. This is like, again, your introductory to geometry. If you can get this down, it makes your unit 1 and 2 in geometry really easy or easier. Okay, so I would not just take a picture, but if you can take a picture so that you can see better, that's fine. But I would actually physically write this down in your notes. Because A, you need it for my class, and B, you're going to need it for geometry next year. Okay. Just a reminder, you learned about the triangles back in 7th grade, maybe earlier. Equilateral is all sides are the same. Isosceles means 2 sides are the same, and scalene means no sides are the same. You learned about acute, obtuse, and right back in 3rd grade. Okay, so acute is less than 90 degrees, obtuse is more than 90 degrees, and then a right angle is 90 degrees. Then you learned about parallelograms, rhombuses, squares, and rectangles. You learned about parallelograms back in 4th and 5th grade. You learned a little bit about rhombuses, but this is the first time you're actually having to do something with it. And then obviously square and rectangle, you learned it in 2nd grade. Okay, you need to list out all these little bullet points because those are the parts that matter. We're getting to the point where we're going to start talking about this fancy word that everybody hates, and it's proofs. Okay, this is like the bane of geometry existence. Everybody hates proofs. This is proving why a shape is what it is. Okay, you will like geometry up until that point. Okay. So with that being said, take a moment and write these things down on your paper. So kind of summarize what you just wrote down. So what are different about these? Okay. What about the sides? Okay. And then what's the difference between parallelogram, rhombus, square, rectangle?
The sides, what are the parallel?
Okay.
And then the angles, what are the
Gotcha. Okay, perfect. Okay, so let's say that we're looking at this blueprint of this house, okay? And we're trying to confirm that the garage is a square. The best way to do that is to find the distance of all of the side lengths and they're all supposed to be the same, and then finding the slope and confirming that they're perpendicular. Well, remember, when we talked about perpendicular slopes, that means that they're negative reciprocals of each other, right? So if you found the distance of all of the garage sides, it's going to be 26.83, which means that it would be a square. Okay, so what I'd like for you to do is just kind of on your paper or somewhere, I want us to find the side length of AB with these points. So the first thing we would probably do is, if you had graph paper, okay, you're going to graph this first. So it would look like this. -5, -2. Okay, and if you need paper, you can come grab some from the table. I apologize for not printing out the correct one. I was in a rush this morning. Now, if I'm trying to find the side length, I'm going to use the distance formula. So just a reminder, here's the distance formula. Yes, you will be given to you on the test. Okay, so we're going to take the side A to B. Okay, so you're finding the distance of this side. Okay, can you take a moment? Can you do that? Distance of A. So when you plug this in, I think it's 5. Pretty sure it's 5. Yeah. Okay, so let's plug it in together. So when we substitute that in, we're going to get -8 minus -5, which will make that positive. And then 2 minus 6. And so this will give me -8 plus 5 is 3 squared is 9. And then 2 minus 4, I'm sorry, 2 minus 6 is 4. 4 squared is 16. So that should be the square root of 25, which is 5. Maybe look at your signs of where you added or subtracted. Okay, so now that we found that side length, you have to find the side length for every single side. And in order to confirm that it's a square, they all have to be the same. Everybody with me on that? Okay, so if it's a square, all sides are the same. Now, if we want to know for sure whether this is a square or it could be a rhombus. Okay, so this could be a square or a rhombus. What's the difference between a square and a rhombus? The angles. How do we confirm the angles? It could be a square or a rhombus. Okay, and how do we know for sure? We could use the slope formula to see if they're perpendicular to each other. Okay, so what we're going to do now is we've got to find the slope of each one of these. Okay, we're going to do this visually instead of having to plug it in, just because it's on a graph. So 1, 2, 3, 4 over 1, 2, 3. So this has a slope of 4/3. For this one, we go down 1, 2, 3, 4. We go to the right 1, 2, 3. So this has a slope of -4/3. Are those negative reciprocals of each other? Are they negative reciprocals of each other? Are they flipped versions of each other? No. So they're not perpendicular. So that's not a right angle. So which shape is this? Is this a square or is this a rhombus?
Rhombus.
It's a rhombus.
Is this on paper?
This one isn't, because I printed out the wrong one. But I'm going to give you all some practice over it in a second. Okay, AD, we already did. Okay, and then BC is going to be 4/3. Everybody with me?
Mhm.
Okay, so you got to find the distance of each shape that you get, and then you really kind of have to find the slope of each side. Okay, that way you can kind of confirm what shape it is. Okay, so if I have these equations, I want to pick 4 to create a rectangle. Which 4 would work? What do we know about rectangles?
One side are the same. No, nine.
They're not all the same.
Oh, rectangles.
Rectangle.
Two.
Opposite sides are the same, right? Okay, so looking at this, they also have to be parallel. So if I have this guy, which one of these is parallel to that one? Ava said E. Yeah? Okay, why? Because that's that -2 out front. Does everybody see it? Okay, so then I need another side that is perpendicular to -2. So which equation would be perpendicular to -2? Perpendicular. So perpendicular means that we're going to flip it and we're going to change the sign. So which one has a positive 1/2 as the slope? F and D. So those would be the 4 equations in order to make a rectangle. Everybody see it? Okay. All right, so what I'd like for you to do is take a look. Yeah, let's do this one. Okay, so you're gonna get into groups of 3. Don't do more than 3 because otherwise it's like one person really doing the work and everybody else is just chilling. Okay, so group members are gonna only solve the columns that they are assigned to. So you're gonna pick a letter A through C. Each student's gonna solve their assigned problem in the row, and then you're gonna use the row to add them up to check their total answer. So each person's gonna do their little part, then you're gonna add it up to get the end. On the back of your paper is where you're gonna record your answers. Does everybody understand that? Okay, so the front of the paper has the problem, the back of the paper is where you're gonna record your answers. You can use one sheet between the 3 of you, but I would prefer if each one of you works your own problem on your own paper and then transfers it to one paper if you can. Okay, once the row sum totals match, students may move on to the next row and repeat the process. So you have 5 rows to get through, 3 problems in each, 3 people in a group, 5 rows, okay? And then you're gonna turn it in by the end of class, okay? You have more than enough time, so you should be okay, okay? Are there any questions about what you're doing or how to do it? Okay, so 3 group members, not 4, not 7, not 16,